Hey, this is Sleeper. Welcome back to my channel. We are continuing the Getting Started module from Hack the Box Academy. If you need access to Hack the Box Academy, you can sign up with the link below. Keep in mind, Hack the Box Academy and the main Hack the Box website are two separate accounts with different plans available. I recommend the Silver Annual plan as it gives you access to all the job role paths, all the modules up to Tier 2, and an exam voucher, good for any of the Hack the Box certifications. So let's go ahead and continue. Staying organized. Whether we are performing client assessments, playing Capture the Flags, taking a course in Academy or elsewhere, or playing Hack the Box Boxes labs, organization is always crucial. It is essential to prioritize clear and accurate documentation from the very beginning. This skill will benefit us no matter what path we take in information security or even other career paths. Folder structure. When attacking a single box, lab, or client environment, we should have a clear folder structure on our attack machine to save data such as scoping information, enumeration data, evidence of exploitation attempts, sensitive data such as credentials, and other data obtained during recon, exploitation, and post-exploitation. A sample folder structure may look like follows. So here we have a folder for the client Acme company with two assessments, internal penetration test and external penetration test, IPT and EPT. Under each folder, we have subfolders for saving scan data, any relevant tools, logging and output, scoping information, for example, list of IPs, networks, to feed our scanning tools, and an evidence folder that may contain any credentials retrieved during the assessment, any relevant data retrieved, as well as screenshots. It is a personal preference, but some folks create a folder for each target host and save screenshots within it. Others organize their notes by host or network and save screenshots directly into the note-taking tool. Experiment with folder structures and see what works best for you to stay organized and work most efficiently. Note-taking tools. Productivity and organization are very important. A very technical but unorganized penetration tester will have a difficult time succeeding in this industry. Various tools can be used for organization and note-taking. Selecting a note-taking tool is very individual. Some of us may not need a feature that another person requires based on their workflow. Some great options to explore include Cherry Tree, Notion, Notepad++, Visual Studio Code, Gitbook, Evernote, and Sublime Text. Some of these are more focused on note-taking, while others such as Notion and Gitbook have richer features that can be used to create wiki-type pages, cheat sheets, and more. It is important to make sure that any client data is only stored locally and not synced to the cloud if using one of these tools on real-world assessments. Tip: learning Markdown language is easy and very useful for note-taking, as it can be easily represented in a visually appealing and organized way. Other tools and tips. Every InfoSec professional should maintain a knowledge base. This can be in the format of your choosing, though the tools above are recommended. This knowledge base should contain quick reference guides for setup tasks that we perform on most assessments, and cheat sheets for common commands that we use for each phase of an assessment. As we complete boxes, labs, assessments, training courses, etc., we should be aggregating every payload, command, tip, as we never know when one may come in handy. Having them accessible will increase our overall efficiency and productivity. Each Hack the Box Academy module has a cheat sheet of relevant commands showcased within the module section, which you can download and keep for future reference. We should also maintain checklists, report templates for various assessment types, and build a findings/vulnerability database. This database can take the form of a spreadsheet or something more complex and include a finding title, description, impact, remediation, advice, and references. Having these findings already written will save us considerable time and rework during the reporting phase, as the bulk of the findings will be written already and likely only require some customization to the target environment. Moving on. Try out various note-taking tools and develop a folder structure that works for you and matches your methodology. Start early so this becomes a habit. The Nibbles walkthrough later in this module is an excellent opportunity to practice our documentation. Also, this module contains many commands that are useful to add to our common commands cheat sheet. Connecting using VPN. A virtual private network, VPN, allows us to connect to a private internal network and access hosts and resources as if we were directly connected to the target private network. It is a secured communications channel over shared public networks to connect to a private network. For example, an employee remotely connecting to their company's corporate network from their home. VPNs provide a degree of privacy and security by encrypting communications over the channel to prevent eavesdropping and access to data traversing this channel. At a high level, VPN works by routing our connecting device's internet connection through the target's VPN private server instead of our internet service provider, ISP. When connected to a VPN, data originates from the VPN server rather than our computer, and will appear to originate from a public IP address other than our own. There are two main types of remote access VPNs: client-based VPN and SSL VPN. SSL VPN uses the web browser as a VPN client. The connection is established between the browser and an SSL VPN gateway, can be configured to only allow access to web-based applications such as email and intranet sites, or even the internal network, but without the need for the end user to install or use any specialized software. Client-based VPN requires the use of client software to establish the VPN connection. Once connected, the user's host will mostly as if it were connected directly to the company at work, and will be able to access any resources, applications, hosts, subnets, etc. allowed by the server configuration. Some corporate VPNs will provide employees with full access to the internal corporate network, while others will place users on a specific segment reserved for remote workers. Why use a VPN? We can use a VPN service such as NordVPN or Private Internet Access and connect to a VPN server in another part of our country or another region of the world to obscure our browsing traffic or disguise our public IP address. This can provide us with some level of security and privacy. Still, since we are connecting to a company's server, there's always the chance that data is being logged or the VPN service is not following security best practices or the security features that they advertise. Using a VPN service comes with the risk that the provider is not doing what they are saying and are logging all data. Usage of a VPN service does not guarantee anonymity or privacy, but is useful for bypassing certain network or firewall restrictions or when connected to a possible hostile network, for example, a public airport wireless network. A VPN service should never be used with the thought that it will protect us from the consequences of performing nefarious activities. Connecting to Hack the Box VPN. Hack the Box and other services offering purposefully vulnerable VMs and networks require players to connect to the target network via a VPN to access the private lab network. Hosts within Hack the Box networks cannot connect directly out to the internet. When connected to Hack the Box VPN or any penetration testing, hacking focused lab, we should always consider the network to be hostile. We should only connect from a virtual machine. Disallow password authentication if SSH is enabled on our attacking machine. Lock down any web servers and not leave sensitive information on our attack VM. For example, do not play Hack the Box or other vulnerable networks with the same VM that we use to perform client assessments. When connecting to a VPN, either within Hack the Box Academy or the main Hack the Box platform, we connect using the following command: sudo openvpn user.ovpn. The last line, initialization sequence completed, tells us that we successfully connected to the VPN. Where sudo tells our hosts to run the command as the elevated root user. OpenVPN is the VPN client, and the user.ovpn file is the VPN key that we download from either the Academy module section or the main Hack the Box platform access page. If we type ifconfig in another terminal window, we will see a ton adapter if we successfully connected to the VPN. Typing netstat-rn will show us the networks accessible via the VPN. Here you can see that the 10.129.0.0/16 network used for Hack the Box Academy machines is accessible via the TUN-0 adapter via the 10.10.14.0/23 network. Help with VPN. If this is your first time using a VPN, the following resources on Hack the Box support portal will be helpful: Introduction to Lab Access and Connection Troubleshooting. Moving on to the pen testing basics with common terms. Penetration testing or hacking is an enormous field. We will encounter countless technologies throughout our careers. Here are some of the most common terms and technologies that we will come across repeatedly and must have a firm grasp of. This is not an exhaustive list, but is enough to get started with the fundamental modules and easy Hack the Box boxes. What is a shell? Shell is a very common term that we will hear again and again during our journey. It has a few meanings. On a Linux system, the shell is a program that takes input from the user via the keyboard and passes these commands to the operating system to perform a specific function. In the early days of computing, the shell was the only interface available for interacting with systems. Since then, many more operating system types and versions have emerged along with the graphical user interface, the GUI, or the GUI, to complement command line interfaces, shell, such as the Linux terminal, Windows command line, cmd.exe, and Windows PowerShell. Most Linux systems use a program called bash, born again shell, as a shell program to interact with the operating system. Bash is an enhanced version of sh, the Unix system's original shell program. Aside from bash, there are also other shells, including, but not limited to, zsh, tcsh, ksh, fish shell, etc. We will often read about or hear others talking about getting a shell on a box or system. This means that the target host has been exploited, and we have obtained shell-level access, typically bash or sh, and can run commands interactively as if we are sitting logged into the host. A shell may be attained by exploiting a web application or network/service vulnerability, or obtaining credentials and logging into the target host remotely. There are three main types of shell connections. Reverse shell initiates a connection back to a listener on our attack box. Bind shell binds to a specific port on the target host and waits for a connection from our attack box. And a web shell runs operating system commands via the web browser, typically not interactive or semi-interactive. It can also be used to run single commands, for example, leveraging a file upload vulnerability and uploading a PHP script to run a single command. Each type of shell has its use case, and the same way there are many ways to obtain a shell, the helper program that we use to get a shell can be written in many languages: Python, Perl, Go, Bash, Java, Awk, PHP, etc. These can be small scripts or larger, more complex programs to facilitate a connection from the target host back to our attacking system and obtain shell access. The shell access will be discussed in depth in a later section. What is a port? A port can be thought of as a window or door on a house, the house being a remote system. If a window or door is left open or not locked correctly, we can often gain unauthorized access to a home. This is similar in computing. Ports are virtual points where network connections begin and end. They are software-based and managed by the host operating system. Ports are associated with a specific process or service and allow computers to differentiate between different traffic types. SSH traffic flows to a different port than web requests to access a website, even though the access requests are sent over the same network connection. Each port is assigned a number, and many are standardized across all network-connected devices, though a service can be configured to run on a non-standard port. For example, HTTP messages, website traffic, typically go to port 80, while HTTPS messages go to port 443, unless configured otherwise. We will encounter web applications running on non-standard ports, but typically find them on ports 80 and 443. Port numbers allow us to access specific services or applications running on the target devices. At a very high level, ports help computers understand how to handle the various types of data they receive. There are two categories of ports: Transmission Control Protocol, TCP, and User Datagram Protocol, UDP. TCP is connection-oriented, meaning that a connection between a client and a server must be established before data can be sent. The server must be in a listening state, awaiting connection requests from clients. UDP utilizes a connectionless communication model. There is no handshake, and therefore introduces a certain amount of unreliability, since there's no guarantee of data delivery. UDP is useful when error correction or checking is either not needed or is handled by the application itself. UDP is suitable for applications that run time-sensitive tasks, since dropping packets is faster than waiting for delayed packets due to retransmission, as is the case with TCP, and can significantly affect a real-time system. There are 65,535 TCP ports and 65,535 different UDP ports, each denoted by a number. Some of the well-known TCP and UDP ports are listed below: 20 and 21, FTP; 22, SSH; 23, Telnet; 25, SMTP; 80, HTTP; 161, SNMP; 389, LDAP; 443, HTTPS or SSL/TLS; 445, SMB; and 3389, RDP. As information security professionals, we must be able to quickly recall large amounts of information on a wide variety of topics. It is essential for us, especially as pen testers, to have a firm grasp of many TCP and UDP ports and be able to recognize them from just their number quickly. For example, know that 21 is FTP, 80 is HTTP, 88 is Kerberos, without having to look it up. This will come with practice and repetition, and eventually become second nature as we attack more boxes, labs, and real-world networks, and help us work more efficiently and better prioritize our enumeration efforts and attacks. That was a mouthful. Guides such as this and this are great resources. StationX.net, cheat sheet, common ports, cheat sheets are great sources for learning standard and less common TCP and UDP ports. Challenge yourself to memorize as many of these as possible and do some research about each of the protocols listed in the table above. This is a great reference. On the top 1,000 TCP and UDP ports from Nmap, along with the top 100 services scanned by Nmap. What is a web server? A web server is an application that runs on the back-end server, which handles all of the HTTP traffic from the client-side browser, routes it to the request's destination pages, and finally responds to the client-side browser. Web servers usually run on TCP ports 80 and 443 and are responsible for connecting end users to various parts of the web application, in addition to handling their various responses. As web applications tend to be open for public interaction and facing the internet, they may lead to the back-end server being compromised if they suffer from any vulnerabilities. Web applications can provide a vast attack surface, making them a high-value target for attackers and pen testers. Many types of vulnerabilities can affect web applications. We will often hear about or see references to the OWASP Top 10, This is a standardized list of the top 10 web application vulnerabilities maintained by the Open Web Application Security Project, OWASP. This list is considered the top 10 most dangerous vulnerabilities and is not an exhaustive list of all possible web application vulnerabilities. Web application security assessment methodologies are often based around the OWASP Top 10 as a starting point for the top categories of flaws that an assessor should be checking for. The current OWASP Top 10 list is: Number 1, broken access control. Restrictions are not appropriately implemented to prevent users from accessing other users' accounts, viewing sensitive data, accessing unauthorized functionality, modifying data, etc. Number 2, cryptographic failures. Failures related to cryptography, which often leads to sensitive data exposure or system compromise. Injection. User-supplied data is not validated, filtered, or sanitized by the application. Some examples of injections are SQL injection, command injection, LDAP injection, etc. Number 4, insecure design. These issues happen when the application is not designed with security in mind. Number 5, security misconfiguration. Missing appropriate security hardening across any part of the application stack, insecure default configurations, open cloud storage, verbose error messages which disclose too much information. Number 6, vulnerable and outdated components. Using components, both client-side and server-side, that are vulnerable, unsupported, or out of date. Number 7, identification and authentication failures. Authentication-related attacks that target users' identity, authentication, and session management. Number 8, software and data integrity failures. Software and data integrity failures relate to code and infrastructure that does not protect against integrity violations. An example of this is where an application relies upon plugins, libraries, or modules from untrusted sources, repositories, and content delivery networks, CDNs. Number 9, security logging and monitoring failures. This category is to help detect, escalate, and respond to active breaches. Without logging and monitoring, breaches cannot be detected. And number 10, server-side request forgery. SSRF flaws occur whenever a web application is fetching a remote resource without validating the user-supplied URL. It allows an attacker to coerce the application to send a crafted request to an unexpected destination, even when protected by a firewall, VPN, or another type of network access control list, an ACL. It is essential to become familiar with each of these categories and the various vulnerabilities that fit each. Web application vulnerabilities will be covered in depth in later modules. To learn more about web applications, check out the Introduction to Web Applications module. All right, so let's go ahead and stop here. Once again, my name is Sleeper, and that's a wrap. Until next time. Hello, hackers. In addition to your learning through Hack the Box Academy, HackTheBox.com offers additional machines and challenges to test your skills. Like I mentioned, it is a separate account from the Academy side with different plans available. You can sign up with the second link below. I recommend the annual VIP Plus plan that gives you access to all the retired machines, which can help you prepare for the CPTS, PNPT, or OSCP. It also offers your own personal instance for boxes and unlimited time with the Pwnbox, which is the in-browser attacker machine. It's what I use for these videos, and it's so convenient. Other than that, good luck on your journey into information security, And here are some more videos to choose from.